This question is very tricky and 90% students can make a mistake very easily. I will explain you how. In this reaction, this group is known as mesylate, and this is very good leaving group because of the stabilization of the negative charge through the resonance like this. And similarly, tosylate can also stabilize the negative charge through the delocalization. So those groups are very good leaving group like halogens. But here we don't have halogens, so this mesylate confusing what is the role of this mesylate. But this is also a better leaving group, so therefore you can do the elimination. Now you have very strong base, but this is bulky. So we know that when you have a strong base, this favors the elimination reaction through E2 mechanism. So there are two beta hydrogen, one is here and another is here. Now we have to understand uh, the product would be according to Saytzeff or Hofmann rule. So we know that in Hofmann we will have less substituted alkene. So here, since the base is bulky and strong, therefore it will not remove the proton from this beta hydrogen, but it can easily remove the proton from this beta carbon. Therefore you will have this product. This is kinetically controlled product. But imagine if you have, instead of potassium tetrahydroxide, if you have sodium ethoxide, or we can say that alcoholic KOH, then in that case we will get Saytzeff product, because the acidity of beta hydrogen is comparable in both the cases. So what we will see is steric factor. So when you have sodium ethoxide or alcoholic KOH, then steric crowding will not be a problematic factor for those kind of bases, and therefore you will have Saytzeff product. So therefore in this case, but in the given reactions you will have only kinetically control because of the bulky nature of the potassium tetrahydroxide. Now the second step is the ozonolysis reaction, but there is a oxidizing agent. So what is going to happen, the ozonide which forms will further undergo cleavage, and this shortcut to make this final product. So remember that the monosubstituted double bond will give you carboxylic acid, and disubstituted double bond gives ketone. So here both are monosubstituted, so what you will get, just convert the double bond carbon to the carboxylic acid like this, and then this will be formic acid. So the correct answer will be D. If you want to understand more about when you will get Hofmann product or Saytzeff product, then ask me in the comment box.